right?
Yes, I'm on the science team of the ROSINA instrument, which is the Rosetta orbiter spectrometer for ion and neutral analysis.
Oh my God.
Yes, so it's actually a very, very powerful instrument, and we're at a very unique position, in fact, historical times, when we were able to orbit a comet for the first time and follow it through its orbit. So we followed it through its closest approach to the sun, and we're still following it, taking measurements. So that gives us a really good opportunity to compare how the activity and the behavior of the comet changes over time, depending on its distance from the sun.
Now, how long has this spacecraft been orbiting, and who put it up there?
Okay, so this is a mission of the European Space Agency, and it took about 10 years to even get there. So it was a very concentrated effort of many, many people on both the American and the European side. And so the spacecraft got there to the comet in August of 2014. So we've been monitoring its behavior closely since then, and we've learned very, very interesting things, and our views really changed a lot about comets and that particular comet in question.
So we're getting cutting-edge research here. You just presented your research. The paper's just been published. You're first author. Tell us what was that research in that paper?
Okay, so when the spacecraft first got near the comet, we're still pretty far away, so over 100 kilometers away from the actual nucleus, which is the body of the comet, essentially. It also has an atmosphere, what we might call an atmosphere, once it approaches the sun, and the ices of the comet start sublimating, which form a very tenuous and very extended atmosphere to the comet. So when we got there, we really wasn't expecting to see anything interesting because we were still very far away from the nucleus, and the comet was still pretty far away from the sun. And so that's not what happened. So when ROSINA started taking measurements of the coma, which is the atmosphere of the comet, it detected that the coma was strongly heterogeneous in the major species, which are water, CO, and CO2. So that was actually a colleague of mine who discovered that, and she published that, and that's a publication in the journal Science. So I essentially followed up on that work, and I looked into the minor species. So what do the other gases do compared to this behavior? And so we found that the coma is indeed very heterogeneous, not only in the major species, but also in the minor species. But what was very interesting is that the minor species either followed water or CO2 more closely. Okay? And that was true for essentially all of them that we looked at, except for one, and that was methane. So that is very, very interesting why methane would behave differently, and we're still trying to figure that out, and that's currently ongoing research that I work on relating that to the nucleus. So essentially, this was just one of the very surprising discoveries done early on in the mission before we even reached perihelion when the comet is very active.